You better pick it up because it's going to go off the table. No, yeah, oh, it's too soon. Let Mummy grab it at the other end. Better pause it before it goes too far. Oh. And you can move it up and down in the same way, and you can see the individual phases of the movement there. If you go to the screen, you'll see again the individual phases of the robot on screen as well. And now I'm going to speed up the process. You can watch it going quick faster now as I. You can run it even faster. Oh, let's see how fast we can get it to go without. Well, let's try that. That's pretty quick. We've lost a little bit of the. Oh, it seems to work fine. Let's stop that there. Okay. Hello. Now this is a little demonstration of inverse kinematics. Here you can see the famous robot Spot Mini by Boston Dynamic in one of their computer simulations walking over some terrain. Now here's a robot which I've prepared on a simulation program called Webots. And here you can see the end piece here is being transformed in various positions based on its X, Y, and Z coordinates. Okay. So this is what is actually happening. This point, X, Y, and Z. So X, Y in this case. So it's a two-dimensional. This is produced by the movement of these two robotic arms through angles theta 2 and theta 1. You can use algebra to calculate the values of theta 1 and theta 2 for a given value of x and y with these limb lengths of d1 and d2. And this can be converted into a programming computational script. And here's my version, which I've written in Python. Next, what you can do is, instead of just using a two-dimensional plane, you can project this two-dimensional plane into a three-dimensional plane offset by an angle theta 3, which would equate to having a hip joint here, a knee joint here, and a foot here, which represents the black circle in the original example. Okay, and so we can derive a programmatic solution the same way. In this case, we have X, Y, and Z as inputs, and the lengths D1, D2, and at outputs we get angle 1, angle 3, and angle 2. I also have my Python program which produces all the display on the right side, and that's here. So this is the code I've written. It has a servo generator. It has an inverse kinematics section, and then it has a gate player, which is this section here. Okay. Right. So don't need it open at the moment. But, the robot and everything's running here. Okay. So this is a demonstration of using my gate generator, which is here. Here you can see my robot, and these are various controls for it. What happens is the robot's given this default pose here, which is minus 75 for the foot locations and plus and minus 40 for the skew. These can be adjusted. So if I move this lever up and down, you'll see the robot can move down or up. And also you can change the skew, which is how far the legs are bending. So if we turn this way, you can see you can move the legs further apart. or nearer together. In this example, we're going to go further apart actually. I'm going to drop the robot down a little bit. This is the actual positions that the robot's foot will go through in the X and Y planes. So at the moment, what's going to happen is that this is forward, this is backward. The robot's foot will move forward, up, and then down again. So it'll form a loop like this. Okay, so let's hit play and see what happens this time. So here the robot is approaching an obstacle. You see its gait. And we'll probably move around as it's going. And we can make it move faster just by dragging the speed slider, or slower. And this is what enabled me to program the gates that you see on the actual robot. Actually, just using the exact same controller. So just to explain, with gates, because they're cyclical, each leg pretty much has to do the same thing. The only difference is the phase in the rotation. So that's what this third stage represents. In this particular set of gates, there's 8 phases, 0, and then the counterpoint is 4. So you've got the front right leg in 0 phase, and then the back left leg in 0 phase, and then the other 2 diagonally opposite ones are in phase 4. If you switch those round, you can get trotting gates or bounding gate. So that's something that I'd like to experiment with in the future. This is the first walking of my robot. So here we go.